Here in this section, we have limits involving infinity, asymptotes of graphs. Definitions. We say that f of x has a limit L as x approaches infinity, and right limit of f of x as x approaches positive infinite is equal to L. If for every number epsilon greater than 0, there exists a corresponding number n such that for all x in the domain of f, absolute value of f of x minus L less than epsilon whenever x greater than n. The question is, how can x be close to infinite? So think of a big number as close to infinite. Of two big numbers, the bigger is closer to infinite. So here we have this one. So looking at this x greater than m, based on this inequality, what this one means is that x is closer to infinity than m. We say that f of x has the limit L as x approaches negative infinity, and right limit of f of x as x approaches negative infinity, that is equal to L if for every number epsilon greater than 0, there exists a corresponding number n such that for all x in the domain of f, absolute value of f of x minus L less than epsilon whenever x less than n. Now for this part, the question is, how can x be close to negative infinity? Think of a small number as close to negative infinity. Of two small numbers, the smaller is closer to negative infinity. So when we look at the inequality x less than n, that means x is closer to negative infinity than n. The line y equal to b is horizontal asymptote of the graph of a function y equal to f of x if either limit of f of x as x approaches infinity, that is equal to b, or limit of f of x as x approaches negative infinity is equal to b. Now here on this part, we have graph of this function 1 over x, finding limit as x approaches infinity, that is equal to 0. So on this part, here on this graph, as x approaches infinity, our graph getting closer and closer to x-axis, and the answer for our limit is close to 0. So limit of our function as x approaches positive infinity, that is equal to 0. And here on this part, as x approaches negative infinity, limit of our function, it's getting closer and closer to what we have here, and that is 0. So limit as x approaches negative infinity for our function, that is 0. Now here on the right side, we have this function is given, and based on this, what we have here, horizontal lines, these are asymptotes. So we have horizontal asymptote, y equal to 1, y equal to negative 1. As x approaches negative infinity, our limit is negative 1. Limit of f of x as x approaches positive infinity, that is equal to positive 1. Find the limit of f of t as t approaches negative infinity. Divide the numerator and denominator by 3t to have our term in the form of sine x divided by x and cosine x divided by x. So here I divided each one of these terms by 3t, both in numerator and denominator. And now simplify. Now I'm going to find the limit of each one of these terms in numerator and denominator. So we have limit of 2 divided by 3t. This is what we have here in numerator. That is 0. Limit of sine 3t divided by 3t as t approaches negative infinity, that is equal to 0. And finally, limit of cosine 3t divided by 3t as t approaches negative infinity, that is 0. So what we have here, this is equal to, we have 0 minus 1 plus 0 divided by 1 plus 0. So the answer is negative 1. Find the limit of the irrational function as x approaches infinity and as x approaches negative infinity. Divide numerator denominator by highest power of x in the denominator, which is x to the 4th power. I divided all these 3 terms in numerator by x to the 4th power, and we'll do the same thing here in denominator. So divide each one of these terms by x to the 4th power. Now simplify. Now finding limit of what we have here as x approaches infinity. This part is 4 divided by infinity, so that is 0. Here 1 divided by infinity, so this is 0. 7 divided by infinity, 0. 8 divided by infinity, that is 0. And what we have here is 5x to the 5th power divided by 6 as x approaches infinity, that will be positive infinity. So this means limit of our function as x approaches infinity is equal to infinity. So here is our final answer for first part. Now we want to find limit of f of x as x approaches negative infinity. So for this part, everything is exactly the same as what I did on the first part. The only difference here, x approaches negative infinity. So again, I divided by x to the 4th power, both numerator and denominator. I simplified here. And now finding the final answer. Here again, we have 4 divided by infinity, so that is 0. Negative 1 divided by infinity, that is 0. Number divided by infinity, doesn't matter what number you have, but here in denominator we have infinity, so that is 0. Here again, denominator we have infinity, so this part is 0. And what's left, we have a limit of 5x to the 5th power divided by 6 as x approaches negative infinity. So the answer in this case, because of having this power is odd, that will be negative infinity. So the final answer for this part is negative infinite. This means limit of f of x as x approaches negative infinity is negative infinity. Find the limit of the rational function as x approaches infinity and as x approaches negative infinity. So here on this part, limit of f of x as x approaches positive infinity, that is equal to, we have to divide numerator denominator by highest power of x in the denominator. So in this case, the highest power in denominator is x to the 6th power. So I'm going to divide each one of these terms both in numerator denominator by x to the 6th power. Now simplify. Now finding limit as x approaches infinity. Here we have 2 divided by infinity, so that part is 0. Again divided by infinity, so that part is 0. Number divided by infinity, 0. Number divided by infinity, again 0. So what we have here is finding limit of 4x squared divided by 9 as x approaches infinity. And in this case, the power that we have here on top, numerator, that is even number. In this case, we have positive infinity, so it doesn't matter if it's even or odd, the answer will be infinity. So this is the final answer for part A. Now part B, we have to find limit of f of x as x approaches negative infinity. So now on this part, I have exactly same function, but the only difference, x approaches negative infinity. So all steps still same. We have to divide numerator denominator by x to the 6th power. Then we have to simplify. And what we have here, number divided by infinity, that is 0. The number divided by infinity is 0. Here is 0. And here on this part, again, we have 0. And what we have is finding limit of 4x squared divided by 9 as x approaches negative infinity. Here, our power is 2, and that is even number using negative infinity. With having even power, the answer will be positive infinity. So instead of negative infinity, here in this case, we're going to have positive infinity. If this power was odd, the answer will be negative infinity. But in this case, we have the power is 2, and that is even. So the answer is positive infinity. This is our final answer for this part. Divide numerator denominator by the highest power of x in the denominator and proceed from there. Find the limit as x approaches the negative infinity. So here what we have in denominator is x to the 1, x to the 2/3, and the highest power is, in this case, is 1. So I divided all of these terms in numerator by x. And we'll do the same in denominator. So it's 4x divided by x plus x, power is 2/3 divided by x, 5 divided by x. Now we have to simplify. So here we have division, we have to subtract powers, and our power is, for the first term, is negative 2 divided by 3. Then we have minus 5 plus 8 over x. In denominator we have 4 plus x to the power 2/3 minus 1. We have negative 1 over 3 minus 5 over x. We can also write this way to have all powers positive. Now finding limit as x approaches negative infinite. Here we have a number divided by negative infinite, so that is 0. Number divided by negative infinite is 0. Number divided by negative infinite again 0. And here same thing, we have 0. So what's left on top, we have negative 5, and the denominator we have positive 4. So the answer is negative 5 over 4. Find the limit of the following as x approaches negative infinity. So for this part, we have x plus square root. We're going to multiply both numerator and denominator by x minus square root. Now multiply numerator and denominator and simplify. So here is what we have in numerator. It's x squared minus 3x plus 9. Now here again we can simplify. So in denominator we have x minus square root of x squared plus 3x minus 9. So this is equal to limit as x approaches negative infinity. On top we have negative 3x plus 9. Rewrite what we have in denominator. And now divide numerator and denominator by the highest power of denominator, which is x. So negative 3x divided by x, 9 divided by x, and denominator here, x divided by x. Now here on this part we have radical. Note that since x is approaching negative infinity, multiplying the radical by 1 over x is equivalent to multiplying the radical by negative 1 and multiplying by 1 over x squared inside the radical. So here inside radical, here in denominator we have x squared, and because of multiplying by negative, here we have positive on this part. So we multiply by negative 1 and multiply by 1 over x squared inside radical. Now simplify. Here we have negative 3 plus 9 over x, 1 plus square root of 1 plus 3 over x minus 9 over x squared. Now finding limit as x approaches negative infinity. Here number divided by negative infinity is 0. Number divided by negative infinity is 0. Here again, number divided by negative infinity, that part is 0. So what we have on top, we have negative 3 plus 0, and here in denominator is 1 plus square root of 1 plus 0 minus 0. So the answer is negative 3 divided by 2. Definitions, we say that f of x approaches infinity as x approaches c, and write limit of f of x as x approaches c equals infinity if for every positive real number b there exists a corresponding delta greater than 0 such that f of x greater than b whenever absolute value of x minus c between 0 and delta. So our question is, how can f of x approach infinity as x approaches c? how can f of x be close to infinity? Think of a big number as close to infinity. Of two big numbers, the bigger is closer to infinity. And f of x greater than b means f of x is closer to infinity than b. We say that f of x approaches negative infinity as x approaches c, and write limit of f of x as x approaches c equals negative infinity if for every negative real number, negative b, there exists a corresponding delta greater than 0 such that f of x less than negative b whenever absolute value of x minus c between 0 and delta. So here on this part, our question is, how can f of x approach negative infinity as x approaches c? How can f of x be close to negative infinity? So think of a small number as close to negative infinity. Of two small numbers, the smaller is closer to negative infinity. So f of x less than negative b means f of x is closer to negative infinity than negative b. Line x equal to a is a vertical asymptote of the graph of a function y equal to f of x if either limit of f of x as x approaches a from the right is equal to either negative or positive infinity, or limit of f of x as x approaches a from the left, that is equal to either negative infinity or positive infinity. Here what we have for y is equal to x squared minus 3 divided by 2x minus 4. So after dividing, we have this part. And in this case, if we try to find vertical asymptote using what we have here in the denominator, 2x minus 4 equal to 0, I'm finding x is 2. So x equal to 2, drawing a vertical line, that is your vertical asymptote. And as x approaches infinity, here this part will be 0, and what we're gonna have is x divided by 2 plus 1, so it's this one. Based on this, what we have here, our slope is 1 over 2, and y-intercept is 1. So finding y-intercept here at this point is 0, 1, and our slope is 1 over 2, drawing this line, that is called oblique asymptote. And then based on these two lines, vertical asymptote and oblique asymptote, we can graph this function. And here on the right side, this is what we have, x plus 3 divided by x plus 2, and that is equal to 1 plus 1 over x plus 2. Vertical asymptote is based on what we have here in denominator, x plus 2 equal to 0, solving for x is negative 2. So x equal to negative 2, that is your vertical asymptote. And then what we have for horizontal asymptote, that is when x approaches infinity. So in that case, this part will be 0, and what's left is y equal to 1. So y equal to 1, that is your horizontal asymptote. And then finally, based on these two asymptotes, we can graph our function. Find the limit as x approaches 6. So here we have this graph for this function. So I used a graphing calculator, and this is what we have. As x approaches 6 from the left, y goes to negative infinity, and that is same for when x approaches 6 from the right. y goes to negative infinity. So here as x approaches 6 from left, y goes down to negative infinity, and as x approaches 6 from right, y becomes very large and negative, so it goes down to negative infinity. That means our answer for this part is negative infinity. Evaluate the following limit of secant theta as theta approaches negative 3 pi over 2 from the right. Here on this part, I have graph of cosine. Cosine is reciprocal of secant. So this is equal to limit of 1 over cosine as theta approaches negative 3 pi over 2 from the right. So here on this part, I have reciprocal of secant theta and secant theta. So this is what we have here on this part. And our theta approaches negative 3 pi over 2. So this is what we have for theta. And based on that, limit of f of x for cosine is equal to 0. This one that we have in black, this is our function. This is secant theta. As x approaches negative 3 pi over 2 from the right, this goes down to negative infinity. That means limit of secant theta as theta approaches negative 3 pi over 2 from the right is equal to negative infinity. So I draw part of the graph for secant here on this part to explain this again. So as theta approaches negative 3 pi over 2 from right, our limit of secant will be equal to negative infinity because this goes down to negative infinity, meaning that our answer for this part is negative infinity. That is our final answer. Graph the rational function, include the graphs of asymptotes. So our first step is finding asymptote. So I'm going to rewrite the rational function and divide x squared minus 16 divided by x minus 1. That is equal to x plus 1 minus 15 divided by x minus 1. Here the denominator x minus 1 equals 0 when x is equal to 1. When x approaches 1, the dominant term of the function is negative 15 over x minus 1 because the denominator becomes very small, making this term very large. Therefore, y is approximately equal to negative 15 divided by x minus 1 for values of x near 1. And find the limit as x approaches 1 from the right for what we had here on that part, negative 15 over x minus 1. That will be a negative number divided by 0, so it's negative infinite. And limit as x approaches 1 from the left. and this will be positive infinite. Because here we have negative number divided by, here x approaches 1 from the left. So that's why here we have positive infinite. Since both limits are negative, positive infinity, the line x equal to 1 is a two-sided vertical asymptote. So as x approaches 1 from the right, this goes down to negative infinity. And as x approaches 1 from the left, this goes up to positive infinity. So when x approaches negative infinity or positive infinity, the dominant term of the function is x plus 1, because the denominator of the term 15 divided by x minus 1, that becomes very large, making this term very small. In that case, what we're going to have is that y is approximately equal to x plus 1, because this part will be 0, and what we're going to have is y equal to x plus 1. And now using this one, we're going to have slope is slope 1 and y-intercept 1. Based on that, we will have oblique asymptote. So the line y equal to x plus 1 is an oblique asymptote both to the right and to the left. Now here on this part graph, we have y equal to x squared minus 16 divided by x minus 1. Our vertical asymptote is x equal to 1. And here we have this line y equal to x plus 1. For the part that we had x approaches negative positive infinity. So we have this line, which is our oblique asymptote, and that is this green line. So this green line is oblique asymptote based on slope 1 and y-intercept is 1. So this is our y-intercept 0, 1. And here this blue line is our vertical asymptote. So here is our graph. So here based on this vertical asymptote and oblique asymptote, and what we had when we try to find limit as x approaches 1 from the left, this graph goes up to positive infinite. So extending that one using this oblique asymptote, we can draw this line. It's getting closer and closer to this oblique asymptote, but it's not crossing it. That is same for what we have here on right side. As x approaches 1 from the right, this goes down to negative infinity. So drawing this one using oblique asymptote, it's getting closer and closer, but it's not crossing it. So here is what we have for our graph.